Okay, so law of sines. I'm going to write out, this is 5, 6. Law of sines is 5, 6. Pay attention, I'm going to be moving along pretty quick today. 5, 6. Law of sines. This should be something easy to remember. Obviously, it has to do with the sine function. Okay? It is A over sine of big A equals B, small b, over sine of a big B, C over sine of a big C. And that comes from a triangle where you have the large letters or capital letters go on the angles, and opposite that capital letter would be the small letters that match it. Okay? This is based off of this type of triangle. This is using the law of sines. Now what you're going to have is you're going to have certain letters that'll be given to you. You might have an angle that's given to you, and maybe the side opposite it, and then maybe they give you this side, and you have to figure out what that angle is. We plug it in. It is nothing more than plugging it in. I'm going to look at this, and let's say my angle here is 65 degrees. My side over here is 12. I'm given a side down here of 8. And I have to figure out what my B is, what my angle B is. It's simply putting it in. So in this case here, we're using A and B. So I'm going to use these two right here. My A is 12 over the sine of my angle, which is 65 degrees, and set that equal to my B, which is 8, over the sine of B. All I did was fill that in. Okay? Now it becomes algebra. Now it's cross, multiply, and divide, right? Cross, multiply, and divide. What is the sine of 65 degrees? Anybody got a calculator real quick? Mine is going to come out. Mine's going to come out in radians, so I don't want to do it on mine. Yeah. 0.906. Okay. Equals 8 over sine of B. Now I'm going to cross multiply. So 8 times 0.906 is what? Eight times that divided by 12. Eight times 9.906 divided by 12. Point what? 604. Now we do an inverse sine of both sides. You guys familiar with inverse sine? Okay. If I want to find this B right here, if you take a look if you got a calculator on your phone, I don't know what it's going to be, but I know if you grab the calculator, it would be sine to a -1. Okay, and that would be what's called inverse sine. So if we took inverse sine of both sides, sine B equals inverse sine of 0.604. This inverse sine and sine cancel each other out. All right? So you end up with, I'm running out of room here, B equals the inverse sine of 604. What's that? Sine to the -1. It's Inverse sine looks like this. 37.15? What is it? 37.15? What did you come?
When I do that button, it just turns into 8 times. Angle is
37.15. We'll just put 37.15. So that would be our degrees right here, would be 37.15. That's how we figured it out using the law of sines. Okay? Law of sines, there's specific times when you want to use the law of sines. You're going to need to be able to figure it out. It will happen when you are working with the same letters, A and a small a, B and a small b, C and a small c. You're working with the same letters, and you're working with just 2 of them versus working with all 3. Degrees, we can work within degrees. You can work within radians. If they happen to give this in radians, which rarely ever happens, right, then you'd work with it in radians, but chances are it's always going to be in degrees. If they give it in radians, then work within radians. If you don't want to work within radians, you can convert it. Minutes, no. I won't be getting into minutes. I am going to be making sure that you understand how to do this. I'm not interested in you doing the little specific things like with minutes. Yes, Citrina? Okay. I want to know that you know how to use this right here, all right? That's what I'm going to be interested in. That is the law of sines. That's what you put on a little note card for your law of sines. You know how to use it. All right. Yeah, A over sine of A, B over sine of B, C over sine of C. And you know it as this type of triangle where your A's, your capital letters are on the angles, and your sides for that are just opposite it. Okay. That's a quick rundown of sines, law of sines. 5-7 has to do with the law of cosines. Law of cosines works like this. Again, we have a triangle like this, where it's set up the same way, where we have our capital letters on the angles. What's that? Nope. Nope, this is different. This is different. Law of sines is actually really easy. Law of cosines, you're going to create the equation that you need to use. Okay? And this is the way it works. A squared equals B squared plus C squared minus 2BC cosine of A. It's also B squared equals A squared plus C squared minus 2AC cosine of B. It's also C squared equals A squared plus B squared minus 2AB cosine of C. All right? It's all the same format. It's just switching the letters around depending on what you need. If I'm looking for my angle C right here, this is the one in question, and I need to find that, I'm going to use this one here with my large C looking with the cosine. Okay? I'm going to use this one. If I'm looking for, let's say, my A, I'm going to go up to this one right here where all I'm working with is 1 A squared of it. All right? They'll probably give you the A angle, and they'll give you B and C, and you need to figure out what A is. That's how the law of cosines works. What you're going to get on what you're going to get on there is they're going to give you three parts of the triangle, and all three are going to be off different letters. They're going to give you, let's say, a B, a C, and an angle A. And you have to find out what the side A is. There's times when you might use the law of sines and the law of cosines to figure it out, depending on what you're looking at. But this is always a three-part. When you're working with law of cosines, you have three parts. You have three different things and three different letters given to you. All right? In the law of sines, you're going to have two-part. You're going to have two letters, A's and B's, or B's and C's, or A's and C's, or something of that nature. Where this, you're going to have three parts. You're going to have a C, an A, and a B. Somewhere with a lowercase or uppercase to work with. All right? Let's do some examples real quick here. Let me just grab one here. If you take a look on page 286, I'm going to take one of the assignment problems here, and let's grab number 15, where B is 7, C is 10, and my angle is 51 degrees. B is what, 7? C is 10? And large C? Large A equals 51 degrees. Okay. And they're asking you in this case, solve each triangle, round the angles and measures. So you're going to have to find everything in this. You're going to have to find your A's, your B's. We're looking for our large B, we're looking for our large C, and we're looking for our small a. We have to solve for that. You might be able to do some of this with the law of sines, but obviously you got A, B, and C here. You're looking at using the law of cosines right off the bat. So what one would I use for this? First one, A squared, right? I'm going to find my A right away. So I'm going to go A squared equals B squared, which is 49, plus C squared, which is 100, minus 2 times BC. 7 times 10 is 70, times 2 is 140, cosine of 51 degrees. Hold on, let's see, this is 51 degrees. Okay? So, let's break it down a little farther. 149 minus 140 cosine of 51. What is that? What's cosine of 51 times 140? Yeah, 2 times B and C. That's where that comes from. You see that, Danielle? Okay. So, who's my calculator here? I want you to give me what this is right here. 149 minus 140 times cosine of 51 degrees. Yeah, I want you to do everything. 149 minus 140 times cosine of 51 degrees. Yep. And keep that number on your calculator too. Don't get rid of it. 5.66. All right, we have A squared equaling 5.66. Let's take the square root of both these. So square root 5.66. Do we need to put plus or minus on this? No, because can we have a negative? No. So we're only using with the plus. A is going to equal what? 2 point what? Take square root of that. 2.3. 2.38. That's our A. $149 minus 140 times cosine. Yeah, you got to multiply that. Well, no, you can do it. It should be able to take care of it if you do it on your phone like that. What do you come up with, Kyle? No. You don't parentheses that. Oh, you Rufus. You don't parentheses this. Minuses at first. All right, let's start this over. And you want to go 140. A squared equals 88.10. Okay. Now I'll take the square root of 88.1. What? I'm sorry. Go ahead.
Cosine 51 times 140 is 88.10.
This is 88.1 minus 149, like that. Okay. What does that come up to? I thought you gave me the whole number. 60.9. Take square root of that. $7.8. Okay, so that's our A. That's our A. 7.8. All right. Now we've got A. I'm going to put this up here. A equals 7.8. Okay. Let me erase some of this. So we got that. Now, what can we use to figure out the rest? Law of sines, right? We can take the law of sines now because we can figure out we got 7.8 over sine of 51 degrees equals, let's do B, which is 7 over sine of B. And we can also use the same one, 7.8 over sine of 51 degrees equals to 10 over sine of C to be able to figure out the other two angles. All right. So once you get that, did you come up with it? Did you come up with it? If you really wanted to figure this all out, B is going to equal the inverse sine of, let's see, 7 times sine of 51 divided by 7.8. Cross multiply and divide. And then I just took the inverse sine of both sides. This one here, C, is going to equal the inverse sine of, cross multiply, divide. It would be 10 sine of, what the heck did I put there? 51 degrees. All right, divided by 7.8. Where are you looking? That's sine. That's part of my sine. 51 degrees. 7 times sine. 7 sine 51 degrees. When you figure them all out, I don't have the calculator right here, and my phone is in radians, so. No. No. Wish I changed my calculator over to radians. I haven't figured that one out yet. All right.